using a WLED controller, the Glowbug PD, version 1.1, with some mistakes to be expected from an early iteration. For more, stay tuned. I'll give a quick shout out to PCBWay for sponsoring this project and sending me the PCB. Thank you again. So this is the board itself before it has any pieces soldered to it. And as you can see, there is a level shifter spot here. There's the D1 Mini, a temperature sensor over here, 2 groove inputs up there, 2 screw terminals to get the VCC, data line, clock, and ground. And you can ignore clock if it's a only 3-wire one with the data out. In addition, right here we have a capacitor, relay, the bypass, which I didn't even use for this because it worked, but in case I didn't want to use a relay for the particular board, I have the bypass there. I have a fuse here to allow an automotive fuse to be put in there. I have a USB-C connector with the WCH CH224K power delivery chip here, the power LED, a bunch of capacitors and resistors over there, a double throw switch to allow me to, on one side, configure the resistance for the CH224K to allow it for either 12 or 5 volt selection, and then the other side to allow for the option of either having VBus be directly, or 5 volts be directly from VBus in the event it's the 5 volt, or in the event it's the 12 volt, it goes through this this linear voltage regulator here to drop it down to 5 volts. Now, one thing, you can't switch it while the circuit is on, because what will happen is when you're in 12 volt mode and you switch to 5 volts for a brief second there, when you switch to 5 volts, it'll send 12 volts through the VBus, or directly to the 5 volt line, and then fry your buffer over here. But yes, then there's the buffer over here to convert the signals very quickly, and that's, I think, the majority of it. I think I mentioned the temperature sensor up here on I2C connectors, GPIO connector. Backside, I have a microphone connector, but unfortunately I need to redo this as I have the pins incorrectly handled for the data and out. I had used an existing footprint on EasyEDA for both the OLED and the microphone, and unfortunately they both have incorrect ordering of the pins. I'm glad I checked before I plugged the things in. This light is one I purchased from AliExpress that I was able to hack here with my WLED controller. Now, in particular, I can't pronounce this thing, so I will have to leave it to those intrepid explorers who follow after me to properly name it. This can be enabled via its onboard button, which controls the relay. The remote can also control the relay. Control via IR remote as well. Quick video, I'm in the 12 volt configuration. I have a small LED strip attached. Because I do not have an LED enclosure that's larger, I'm going to turn on the power. You hear the relay click. I'm going to cycle through the colors real quick. I'll go to purple, up towards pinkish red, now to red, orange, yellow, green, tealish blue, blue. So yeah, 12 volts work as well. Pretty neat. The issues of the board, the primary problems are that I used an incorrect footprint for the microphone and OLED display. I had grabbed them from the community footprints, and they just had the VCC and ground backwards and other random things. So I'll have to look into that further. In addition to that, I wouldn't have been able to use it because the ESP8266 isn't really supported in the audio reactive branch. There's like a whole separate one, but it wasn't really compiling for me anyhow, so I decided to just skip it for this, and I'll come back with an ESP32. I probably should be using something more powerful if I want audio reactivity anyhow. In addition, I removed the variable resistor because I was running into some problems when I was trying to use it. I don't know if I broke the physical one when I was soldering it, aspects of it. I think that's it for the most part.
Like and subscribe to the video to stay tuned for more content.